So today we're going to talk about landing a helicopter in what I call the ultimate confined area. Now a helicopter can land in a really tight space. Normally if you got room for the rotor blades or the rotor diameter, you can land, pick up somebody, drop somebody off, all those kinds of things. Or you can put one side of the helicopter on the edge of a cliff, have somebody get on and off. Those are all confined areas. However, I'm going to talk about the ultimate confined area because those places don't move up and down, right or left, or move in a corkscrew motion. And I'm talking about ships, but not this kind of ship. This is an aircraft carrier. It has 6.5 acres of steel where you can find a spot to land on. In this case, you can see the helicopters in what we call the forward end of the angle. But I'm talking about landing here, the back end of a small ship. And for the sake of discussion, I'm going to use the word destroyer. Now, I've landed on cruisers, I've landed on frigates, I've landed on corvettes, but they all have one thing in common. It's a very small area, it moves up and down, it rolls left and right, and sometimes actually goes in a corkscrew. So it's going up and down, left and right as you're going through. This happens to be a U.S. Navy Burke-class destroyer or DDG. So let's go back to the beginning. So when the U.S. entered the war in Vietnam, the helo decks were not standardized. Okay? Many of them were added after the ships were built. And this is, these drawings are from the actual publication called Splash, which I'll talk about in a few minutes. And it's two ships in the same class, two numbers apart, built by two different yards. And what the notes in the center say is essentially these helo decks were added a year apart, and they're totally different. And yet they're on the same class ship. So the Navy came up with this thing called the Splash publication in 1969. This actually is my copy circa 1970, and the drawing you see on here is the USS England, but to give you an idea, this is two ships in the same class. These are DEGs, or Destroyer Escort Guided Missile, and you notice the helo decks are totally different. And it wasn't confined to destroyers and small ships, but these are two supply ships, and again, same class, built pretty close together, and the helo decks are totally different and they're marked totally differently. So what the Splash publication was an attempt to do is to provide the pilots with some kind of information on what the helo deck looked like, what the nav aids and what services were available on each ship. And the good news was that we had the information. The bad news is it wasn't always current. So this is the Sterret in the Persian Gulf, the Gulf of Tonkin in 1970. You notice this is the diagram from the Splash publication. And if you look at the markings on the deck, on the helo deck, you'll notice they're totally different than what they are in the diagram. This was not uncommon. So when we, post-Vietnam, when we started building ships that had helo decks, the Knox-class were one of the first ships designed with an embarked helicopter detachment. And the reason I picked these two ships, these two photographs, is if you look at the Knox-class ship on the left, you'll notice it has a helo deck, but on the back, it has what they call a CWIS, which is a close-in weapon system designed to shoot down cruise missiles. It was added afterwards. On the one on the right, with the helicopter hovering over the back end of the deck, you see a Sea Sparrow launcher. So those are the kinds of differences that we had to deal with. Again, this was from one of the first ships designed to have an embarked helicopter detachment. And you notice on the picture on the right, you can see the helo hanger and the door. So you'd have to follow the helo's rotor blades, pull it into the hangar. So the Navy came up with a program called LAMPS, and it stands for Light Airborne Multi-Purpose System. Really what it was the first helicopter designed to operate off the back end of a ship and to do certain things. In this case, anti-surface warfare and anti-submarine warfare. The first LAMPS helicopters were H-2s. They were all converted from H-2Cs or Ds, and they had a pilot, a naval aviator, not a naval flight officer, who acted as the co-pilot, and the tactical coordinator for the mission. Could carry one torpedo. It had a radar which sat underneath the pilot's seat. It could drop centibuoys, and it had a thing called a MAD detector, which was a bird, or it's a little tube that hung below the helicopter and trailed it about 50 feet below and 150 feet aft, and you towed that across over the water about 50 feet, and it could detect the magnetic signature of a submarine. And it also had an electronic intelligence gathering system. The one on the H-2 or the SH-2F, which this one was pretty crude, but we got better. Then the next generation was the LAMPS 3, and this was a step change over the LAMPS Mark 1 or the H-2s. This is the H-60 reconfigured and redesigned for the LAMPS mission, and it's now pretty much the Navy's standard helicopter. So on the LAMPS helicopter, we suddenly had the MAD gear, we had a IR infrared jamming system to enable us to protect ourselves against infrared missiles. We had an onboard sonobuoy processor. We had a FLIR system to look at things in the dark. We had an electronic surveillance system. We had a radar, and we could shoot guided missiles. Initially, it was the AGM-119, known as the Penguin. It's built by a Norwegian firm called Kongsberg Weaponsfabrik, and it could go out 60, 70 miles. So now with LAMPS Mark III on the back end of a destroyer, you could go out 100 miles and be the eyes and ears of the ship. You had some staying time. You could hunt submarines. You could hunt ships. And this is a pretty good helicopter. The big difference from the Army's version and this one is, one, the blades folded, and two, they moved the tail wheel from aft into the fuselage underneath the tail just after the cabin. And obviously the systems are a lot different. So the Perry class frigates, the Spruance class destroyers, the Ticonderoga class cruisers, and the Burke class destroyers were all designed with a helo deck, and they're all designed for the H-60. So you can see that we built a lot of these ships with the idea of housing a helicopter detachment, either one or two helicopters on the back end of the ship, and they were part of the ship's company, and the helicopter's capabilities were integrated with the ship's weapon systems. So again, all these ships had an over-the-horizon capability to go hunt submarines and or hunt other surface ships. Comparison to the decks that I saw in the 1970s, 69, 70, 71, 72 off Vietnam and early in my career, the Spruance class helo decks and the Perry class helo decks were huge improvements. They were somewhat standardized, and what you see here in the red arrow is the H3, which has the biggest rotor diameter at 31 feet, or rotor radius, excuse me, and that's how close it came to the superstructure of the ship. But back in Vietnam, we sometimes had less than 2 or 3 feet between the tips of the rotor blades and the superstructure of the ship. Now you have 6, 7, 8 feet, which in helicopter parlance is a lot of room. And then when we get to the Burkes, it's even bigger. You have maybe 10 or 15 feet between the tips of the rotor blade of an H3, and even more if it's an H60, an extra 5 feet, because that's the difference in the rotor diameters. And again, you can see a lot more information. So this is what is in the equivalent of the Splash publication today. It's a lot more information, it has a lot more detail, but unfortunately, still trails in reality. So that's a little bit about the history of the helo deck. Let's talk about getting aboard. So one of the unique things that came about in helicopter flight deck design on the back end of ships was a Canadian invention called bear trap. The Canadians operate in the North Atlantic and the North Pacific, and to put it mildly, the sea is never really very calm. So they developed a system where the helicopter lowered a probe to the deck. It attached to this thing that looks like a giant bear trap or a lattice. And it was attached, you snap that thing in there, and then the helicopter was slowly winched down to the deck. The helicopter pilot flying would then lower the collective to reduce power. You got it on the deck. Now the helicopter is secured, so the ship is pitching and rolling. It doesn't move around, and now you can pull it into the helo hangar after you fold the blades. It's a pretty cool system. It's used by a lot of navies, and it really added, it took a lot of the difficulty out of landing on the back of a pitching and rolling destroyer. However, the question is how do you get from this view on the left, which is approaching, this happens to be the Sterret, it happened to be in the Gulf of Tonkin on a nice windy day, and this is an H3 that's on the back of the Sterret. You can see there's not a lot of room. And then I tell people this is why I have lots of gray hair. So it all starts with finding the ship, or the boat as we refer to it. So there's 3 basic scenarios. One is if you're in instrument flight conditions, you're flying through the clouds, you've got a radar on board the helicopter, you can use it to find the ship, or the ship can use its radar to find you. You let down to about 200 feet. If you're not below the clouds, you keep coming down. Hopefully you'll get below the clouds unless it's a heavy fog, and you drive towards the ship. Now, if your visual flight rules, you see the ship, you get into position about a 1/4 mile, and that's from the port or starboard quarter, and that's where the approach begins. However, the U.S. Navy and Western Navy operates in this condition called emissions control, which means the ship is not emitting anything. No nav aids, no radars, nothing. And so what you as the helicopter pilot have to do is find the ship and then get aboard without talking to anybody, without them being the ship, using any of its navigational systems or aids that emit an electronic signal. Now, if you're back in the days when the helicopter didn't have a radar, you basically went out 100 miles or whatever distance it was, and you did your thing, and you came back, and you hoped the ship was anywhere near it was. We used to have this thing called a Mark I plotting board, which we could plot the relative motion. We knew what the ship was theoretically going, and then we could fly back. Normally, you'd see the wake before you saw the ship, and you follow the wake to the ship. By the way, the Mark I plotting board is something we naval aviators have been using since before World War II. And this is all, again, before the days of GPS, because GPS only tells you where the heck you are. It doesn't tell you where the ship is going. So now as you've seen the ship, or you can see the ship, how do you get aboard? So normally you're somewhere, if you're cruising along between 500 and 1,000 feet, going 100 knots, you descend to about an eighth to a quarter of a mile to about 50 knots, and around 200 feet, 150, 200 feet, it's up to the pilot, and you get into this thing called a creep. And the creep is less than 20 knots, and you're about 100 feet over the water. And when you get to about 100 yards from the ship, you stop. Here's why. Well, the ship is not really going into the wind. The ship is going in a direction so that the wind is either 30 degrees over the port side or 30 degrees over the starboard side. This diagram shows it coming over the port side. So now you're 20 feet. What you're really doing is looking at the motion of the ship. Okay, and then you start creeping forward less than 20 knots, typically about 10 or 15 knots, basically just enough to catch the ship. Once you get to the ship, you then get ready to do what I call fly formation with the ship. So as you get closer, you start to get into what's known as the burble. The burble is caused by the wind coming over the superstructure and also the exhaust gas coming out of the stacks. The exhaust gas you can taste. It generally has particles in it, and it's got a really nasty acidic taste. So we burn JP5 or jet fuel today. Back in the old days, we used to burn this thing called Navy distillate number 2, which is like a heavy black oil, and it was really nasty. But jet fuel just has small particles in it, and you literally can smell it and taste it. Anyway, it's part of the burble, and it bumps you around. Depending on how fast the ship is going, how much power is being generated, the burble varies pretty much every time you come aboard. And you're also at this point looking at the movement of the ship, because essentially what you're going to do is as you creep over the edge of the flight deck, you're going to fly in formation of the ship. So what you do is you get in position of the ship, and you want to stay as it's going up and down, left and right, but you're trying to get the helicopter over at what's called the spots, which you can see pointed out in this shot, and there's also a landing signal enlisted guy. This is one of the enlisted member of the dead who's standing there, and he's guiding you left, right, forward, back, and your air crewman is also looking down. You can see the air crewman's head sticking out of the door of this H-60, and you want to get over the spot, typically about 3 or 4 feet over the spot. Once you're there and you've got the relative motion adjusted so the helicopter is following the ship, you plant it, and I mean plant it. The collective goes down, and you land smartly. And then 2 guys come out, put chocks and chains down. Now, if you're using RAST, you don't necessarily have to use the chocks and chains and you're winched down. But most of the landings are done this way. And once you're on the deck, you can see this helicopter, the main mounts are on the spot, and the sea is relatively calm, and the rotors are stopped, and now you're chocked and chained, and everybody gets out, you shut down the rotors, and you're there. And this happens to be an early model Burke class destroyer without a helo hangar. So you're basically on board, and everything's hunky-dory. So if you like this video, go look at some of the other ones I have on my website. You'll find ones about World War II aviation. There's one about how to fly helicopters and why they're difficult and dangerous to fly. And there'll be others later on about flying helicopters and getting on and off ships. Thank you for watching.